All right, this is part number 2 for the software series on the CNC. If you guys haven't seen part number 1, I highly recommend it. We may have gone on a bit of a rant about Mach 4, but it's pretty entertaining. This, however, is going to be all about Mach 3 and the screen set that I've created for it. I really don't think I've seen anybody do anything like this with Mach 3, so I think it's going to be pretty interesting. So let's check it out. All right. I know what you're thinking. You went from Mach 4 to Mach 3. What are you doing? Yeah, this is Mach 3, and we're talking about interfaces. This, I thought, was probably the worst looking interface I've ever seen. By the way, if you guys don't know, I'm a graphic artist. I'm a UI and UX developer. It's part of my job professionally to make UIs. So when I see this and I have to use this every day, it makes me cringe. It's like going to the gas pump and seeing 400 buttons for 3 options. It's nonsense. So yeah, I started thinking about it, and I noticed on Mach 3's website that they have screen sets that people have made, and I thought, oh, thank God, somebody has made a modern version of Mach 3, and I'm excited to use it. So let's go to Mach's website and check it out. Newfangled solutions. How about old-fangled solutions? Be positive, Mike. Be positive. Downloads and updates. Screen sets. Oh, well, those aren't any better. Actually, these are worse. How do people make it worse? Let me see if I can make this a little more full screen. It's a little blurry, but yeah, sharpness isn't going to help it. That is an ugly screen set. There's one at the bottom here that piqued my interest, though. Again, fuzzy, I apologize. I could download these and install them, but they're not worth it. But this one looks like it was designed for touchscreen. It looks relatively modern. It's got a decently flat design. And just looking from what's there, it might actually have the things that I need most of the time. There's one problem. It's completely in French. I do not speak French, obviously. So I could translate this, and I started doing that. I started taking this exact layout and going in and translating all the text using the screen set editor, which is actually fairly functional. But the UI designer in me just was crying to be put to work. So I took this as an inspiration. This is called Swiss U, and the guy that makes it, props. It's a great start and a great inspiration. So I took this as inspiration, and I've made my own. So this is the Physics Anonymous screen set for Mach 3. I will be making this available for free on our website. So if you're using Mach 3 and you're tired of it looking like your computer is from 1991, and admittedly you're running a CNC with it, so maybe it is from 1991. But I went and bought a new computer and a beautiful new 16:9 touchscreen just for this purpose, and maybe I'm in the minority there, but I wanted something to look nice. I think personally this looks pretty good. And it is, believe it or not, simplified much more than the other screen sets for what you need. So let me kind of walk you through my thinking here. First of all, you might be amazed that Mach 3 supports 16:9. And in fact, it sort of does. You can create the screen set to whatever size you want. Now, if you set it to 1920 by 1080, the standard 16:9 high def monitor resolution, it does some really weird scaling, and it took some experimentation to figure out what its real resolution is, which is basically the full resolution minus the start bar and minus the menu bar on top, plus a tiny bit on the sides that it subtracts as well. But once I figured that out, all the text, all the imagery looks nice and clean. So let me walk you through it here. First, you've got your kind of main window for your G-code. This is showing what G-code it's running. You have your MDI just below that. You use that to input specific commands if you want. Like if you want to tell the machine to go to G50, Z50, X25, whatever, you can put that in there. Then you have your section up here that is specific for loading and unloading files. The icons should make pretty logical sense. The folder icon opens your files. This will show you recent G-code that you've loaded. This is the G-code editor, which is nice because it unloads the G-code from Mach 3 when you do this. So it makes it writable because it actually protects the G-code file when it's open, which is really nice so that the file can't be modified when you're running G-code. if I'm somewhere down here and I want to go back up at the top, this rewinds it all the way to the top. If I am somewhere on this list and I want to start from here, I click that button and it'll start from that position. Be careful with that one because it'll just start reading commands from there. So you want to be, between tool changes, between operations, that type of thing. Because it might, if you didn't tell it to turn the spindle on, it won't turn the spindle on. Scary stuff like that. So be a little careful with that. The single line button will let the G-code run line by line. That's kind of useful when you're trying to diagnose something or you want to get back to where you were. This is the line you're on. You can type into this and it'll go straight to that line. I only have 78 lines in this piece of G-code, and X will close the G-code. Play, pause, stop, pretty obvious. This set tool height, probe Z, and probe corner, I'm going to get into more when we get into the probing section. But I put these shortcuts right up at the top because I use them all the time and they're really helpful. I've modified some of the macros, and I'll talk about the guy that made the macros of that as well when we get to the probing section, because he did a phenomenal job. I want to give him credit. I only had to make some pretty minor modifications to make them a little more safe and a little more useful. Probe activity, this tells me if the probe is being active. It is currently being active because it's not plugged in, and that's the way safety probes should be set up. That way, if something disconnects for any reason, it detects the probe as active and not the other way around. Dwelling, that'll tell you if the machine is waiting on something. If you've got a dwelling operation to wait, that light will blink. Constant velocity, that's the mode you're in. This WCS, that's called the work coordinate system. I think Mach 3 traditionally doesn't call it a work coordinate system. They call it a setup. In fact, Fusion 360 also calls it a setup. Work coordinate systems are usually, in G-code terms, G54, G55, G56, so on. These are just called 1, 2, 3, 4. I think it goes up to 8, something like that. So you want to make sure if you've got several work coordinate systems that you're on the right one. That's there. Again, you can just type that in. If you type it in there, it'll automatically go to G55. Jogging, this enables and disables jogging on by default. Thank you. This is the mode, continuous or incremental. That means, if you're pressing and holding the button, the machine is going to continue to move. Incremental, you press it once and it only moves the increment you have set, which is what this is set here. Right now it's set at 1,000, which is really useful for diagnosing backlash, which is what I was just doing a few minutes ago. You click it once, your dial indicator should read 1,000. If it doesn't move, you've got backlash. You can change the jog increments by clicking this, and it'll cycle through some preset jog increments. You can set that within Mach 3, which is pretty convenient. Then you've got your X, Y, Z, and A references. This is the machine coordinate set to 0. That means your machine has been referenced. So if you've homed your machine, it should automatically set those positions in your machine coordinates to 0. My machine doesn't because I've got hard stop homing, and the servos that I'm using from Technic don't talk back to Mach 3 to tell the machine that it's homed. So I'm still working on that. I think there may be a system to do it. I just haven't set it up yet. So when I turn on the machine, it homes itself. It stays in its 000 machine coordinate position, and I hit reference all, and it automatically sets them to 0, as opposed to homing the machine. That's what the reference all usually does. It homes the machine. Then you've got X, Y, Z, and A0. This will set your local coordinates, not your machine coordinates, to 0. So if you click those, your locations will go to 0. A0, because I don't have an A-axis set up. You've got your go to X, Y, Z, 0. I think I may change this out to just X, Y, 0, because going to 0, Z can be a little scary, depending on where your datum is set up. Your 000 for your work is. So I may change that. Actually, that's a good time to bring this up. If you see something in this that you'd like, why would you do that? Everybody else does it this way. I will definitely listen to that, and we may make some changes, because I am not a CNC expert. I think actually most people that use Mach 3 probably aren't CNC experts either, and I found there's a lot of kind of weird habits going on. Like setting up tool heights is not really very common for Mach 3 users. They don't use the actual tool offsets. They just set the Z0 at the bottom of the tool every time they change tools. This makes sense if you're running a router and you just have to physically pull a tool out and put it back in, and you have no idea where it ends up. But I'm using TTS colors, so they always have a referenced surface. And so as long as they're in the tool holder at all times, then I know exactly what that offset is and I can set it. That's what that tool height offset button does, but I'm getting ahead of myself. If I load a piece of G-code. One thing I did not think I was going to use, and it was already in the Swiss U when I started this process, and I thought, you know, I'll leave it in there and see if I use it, are these X, Y, Z, and A minimum and maximum numbers. Turns out they're super useful. For example, if I have probed the top of my workpiece when it's in the vise, and I know that's the top, and I open my G-code and I say, well, my Z minimum is, you know, about 5/8 of an inch down, and my part's only sticking out of my vise 1/2 inch, I'm going to run into my vise. So it's a good double check to use. So I actually have started using those. It's pretty good. Soft limits on by default. I don't know why that was so hard Mach 4, but you can turn them off if you, for some reason, have reason to move your machine past its soft limits. I have my soft limits set pretty accurately, so I leave them. The feed rate is what it's being asked to do. The actual feed rate is what it may be doing. So I've got a feed compensation here. So if I want to run at 50%, you see it's being commanded at 10 inches a minute, but the actual is 5 because it's 50%. Cool thing about Mach 3 is you can go all the way up to 250%. I think it's pretty cool. And this is what it's actually moving while you're moving the machine. So it'll account for acceleration and that type of thing. And you get this nice override blinky button that is telling you your feed rate is set to something other than 100%, and it's a good warning. So if you happen to, you know, run it at 250%, you start the next operation that shouldn't be run that fast, this is kind of a warning to do so. You also have some arrows if you want to just scroll up and down with that. Jog speed, this is how fast the machine is going to jog. Super helpful. I've set this to 2% because we're being really careful about moving the head back on the machine. This is your tool information. This is the tool number that's selected. The diameter of the tool are all set in your tool table. You can also set them here, which is pretty cool. So if I decide tool 39 isn't a 1/2 inch, it's actually 1/4 inch, you can set it and it'll update your tool table automatically. Set that back. Tool height offset. This was set by the process of doing tool height offsets in the probing section. Coolant, this turns on and off the coolant. And M1 brake, that means it's going to stop between every operation whether there's a tool change or not. This is pretty helpful for diagnosing problems, or if you want to run one and then take a look at your workpiece, make sure there's no chatter or something like that. M1 brake's kind of good, but I have it set to off by default. Your spindle, this turns on and off your spindle based on the RPM you want. This would show the actual RPM. I do not have a sensor in my machine yet to feed that information back to Mach 3. So it just assumes based on you know, the values that it's putting out to the variable frequency drive that it's just going the right speed. Not the best way to do it. I'm going to upgrade that at some point. This is your jog buttons. Word of warning on these. The combination of Windows and Mach 3 doesn't really like a touchscreen interface for this. When you click a button, it takes it as a click and you let go, whether you're holding the touchscreen down or not. It doesn't seem to have a way of holding a click down from what I've seen. If you guys know of a better way, let me know. But the result of that means if you press and hold the button, it's going to move for a very brief second and stop because it thinks you've let go of the button. If you're using a mouse with this system, it works just fine. Then you've got your window that is showing the paths from your G-code. Follow, if you click that, it's going to keep the center of the spindle in the center of this window so you can watch it move. Pan view, so normally if this isn't clicked and I click on this screen, it's going to rotate. The way it does this isn't super intuitive in my opinion. I've always had a little bit of trouble with that. But if you double click, it'll go back to the ISO grid. In fact, if you double click it again, it'll go to this kind of default window. But pan view, when that's selected, if I drag this is more helpful to me. And pinch to zoom even works. Cool. These top view and full screen views don't do anything yet. I'm going to come back to those. And you've got your log here, which will show you any errors you've had in the past. Pretty helpful. And this bottom bar will show you the current error down here in the info section, along with the file you have open and the modes you're in. So if you're in, you know, anything that's modal, like G54 or G94, or any of those, they're going to show up here. So that is everything on the main screen. Let's go to the G-code section. This is the last screen. I'm just going to go to it because it's quick. This shows you all the generic G codes and M codes. This list I pulled from the internet, and I think I'm going to change it out. I've noticed that some of the descriptions aren't great, so I'd like to find a more comprehensive list. If you've got one, let me know down in the comments. This is the diagnostics window. If the guy who made Swiss U is looking at this and going, hey, that's my layout, it sure is. I didn't change a thing. To be honest, I don't use the diagnostics page all that much, and the way he had it laid out seemed logical enough. I'm not actually sure what most people would want to see in the diagnostics page. If there's something specific, again, let me know. But for my needs, this has worked out fine. All right, and finally, the probing section. So a lot of this work in the probing section is not mine. I used a ton of macros that were made by a company or a guy, not really sure which, called first.by. I'm going to link to all of these guys in the description, by the way, if you want to check them out. I want to give them a huge amount of credit for this because they've clearly put in a lot of work. In fact, when you start digging into the macros, you see a ton of stuff that will be like, originally created by, and then underneath that it'll be, edited by or modified by. So there's probably a long history of some of these macros, and they work really well. So we'll start in the settings page here. I don't have great descriptions on these yet. I think the guy that wrote it did a better job than I did, and I'm going to revisit the names here because after using it for a little while, I'm not even sure what some of these are supposed to do, but I'll try and walk through them. Search speed is how fast it'll move into the part with the probe the first time as it's trying to find the position. It does this once and then moves to a slow speed to get a more accurate reading. So those are those two speeds. Search distance is how long it'll move into a part before it decides that it hasn't found it and gives up. I think the proper setting for this is the travel of your probe. That way, if you are running into a part and it's not finding it for some reason, your probe isn't being active the way it's supposed to, then it'll stop before it breaks your probe. Slow distance is how far it moves away from the part before it starts its slow speed run. You want this to be a small distance because it's moving the machine slowly, but you need it large enough that it has deactivated the probe before it starts again. Stylus tip, this is your tip diameter. Interestingly, this is not the tip diameter that you measure on the tip. This should be 1/8 of an inch, 0.125. You see I have it set to 0.113, and that is because between hysteresis in the machine, the electrical conductivity of the probe itself, and when it deactivates, it ends up to be a little smaller than the tip. And that's been calculated based on some calibration that I did. So if yours isn't exactly the diameter of your probe or you're getting some weird measurements, that's probably why. XY clearance, this is how far over from the part it's going to start its run. Edge length, that's how far in the other direction. I'm going to get into that a little bit more as we actually do some probing because it's a little tricky. And the search depth, this is how far down it's going to move before it starts probing. And that is actually brings me nicely to the next section, which is how you do the probing. So let me set up a workpiece real quick and I'll try and show you a demonstration. All right, if you're interested in these little toe clamps I made, I'll make the models available. I have no idea which vices they'll work on the ones that I've got, and I'll link to those in the description. I do plan on making these out of steel at some point. They're made out of aluminum at the moment. All right, so the basic probing operation goes something like this. You move the probe roughly above the corner of the part that you want to probe. We've got a lot of corners to choose from. You can do inside corners, outside corners. You can even do inside and outside of diameter of a bore or a boss. You can do centering operations as well, but for this demonstration, I'm just going to use one of the corner operation probes. So I've got it about where I want it. Based on these defaults, the probe, if this is the corner of my part, is going to move over this direction and this direction by 1/4 of an inch. It's going to move down 0.4 inches, and it's going to move over at least 1/2 an inch, and if it hasn't found the part by then, it's going to give up. And then it'll come up over the part and do the other side. So this corner probe will do both corners at a time. It'll automatically set those 0 points in your X, Y, and Z coordinate system. And it'll do it based on whatever coordinate system you're in at the time. So let me press the button, make sure everything else is good. The first set of moves it does is going to be based on the feed rate you have plugged in here. So I'm going to set that to 30. That's its kind of free jog move speed. So let's press that. Over, down, into the part. Now, you'll notice a few things from that demonstration. First, the machine didn't suddenly drive the probe into the workpiece. It seems like I shouldn't have to say that, but here we are. It did this because it captured its current position. It said, this is where I'm at right now. I'm going to base all the moves ahead of this based on that position. So you don't have to go in here and set 0 to do it. You don't have to, in this case, because we're probing X and Y, it doesn't even care what tool is technically in the machine because it's not using any height offsets. If I were to try and use the Z probe, it would yell at me and say, you've got tool 39 in there. You need tool 99 in there so that I know the height offset of your probe. In fact, let me do that right now. I'll show you how that works. Move that over, move that over. So I'm just going to probe the top of this workpiece. I'm in tool 39 right now. I hit probe Z. Guess what? Nothing happens. We get this little info window that says tool 99 is not selected, exiting. So I go ahead and tell tool 99, if I can type, which I can't. I've got a height offset preset in there. I can show you how we set all those tool height offsets as well. Pretty cool system for that. It's above the part. You just have to be somewhere above the part. It will give up after its search depth, which is 0.4 inches at the moment. Click the tool, the probe Z, it's going to go down, it's going to measure it, it's going to measure it again at a slower speed, and it'll even go back to where you set it initially, which is pretty handy. And there you go. You've got your full datum set to the very corner of this part. By the way, both of those buttons that you need to do that on the main screen as well. That's why I put them there, because that's how I set up most of my workpiece datums. And you'll notice everything else on this side of the screen looks pretty much like it did on the first screen. There are a few things that are bigger, but you'll recognize most of them. This little results page is pretty convenient. It'll actually show you the discrepancy that it got from where you had your position set initially and where you didn't. So for example, if I come over here and I'm going to probe this corner again, because I've already probed the corner, it already knows where that 0, 0 is supposed to be. This X plus and Y plus should come out to both be about 0. There you go. X is within 2 thou, Y is, it says 0, 0, 0, which is pretty cool. This results page is actually super helpful for doing your calibration of your probe tip as well. Like I put a workpiece in here of an exact known dimension, in this case a 1, 2, 3 block, and I measured each side of the 1, 2, 3 block, and it'll tell me the X plus, X minus, and the delta between the two. So if it says exactly 3 inches, then I've got the probe tip right, and I calibrated it that way. You see here now we're within 1 thou. Pretty accurate enough for the stuff that I do. All right, the final thing I want to talk about here is these tool height offsets. Again, I don't think most people that are using Mach 3 are using height offsets, at least not in the way that I've been trained to use them, or the way we figured out how to use them in the tour Mach world, you know, with PathPilot. But the way the TTS system is designed to work is your 0, which means no tool height offset, is actually the bottom of your spindle with no tool in it. And everything else gets an offset based on that. So in this case, you know, the offset is from here to the bottom of this probe. To measure that, I use a tool height offsetter. This is a nice wireless one that we got on eBay. I'll link to it in the description. It's actually smarter than you think it is. Having a wireless probe probably scares a lot of people. To be honest, it did me a little bit too until I started using it and I figured out how it works. It's got a few nice safety features. It turns itself off after a little while, so it saves battery. And when it's off, it'll tell the receiver on the other end that it is off and that it is being active. So it constantly acts like a probe being active. Same way this does when it's being unplugged, which is pretty nice. When you click it the first time, it'll power up itself. It'll tell you that the probe is being clicked. The RF light here tells you it's communicating with the receiver. The low power light will come on if the battery is dying. It'll give you ample warning. When the battery finally does die, it is smart enough to recognize that it's not communicating with this anymore, and it'll activate your probe and you're likely not going to crash into anything. One thing about Mach 3 that is frustrating, and something that Mach 4 did better, is Mach 3 only allows you to have one probe at a time. It only allows one pin for the probing function. And you can see I've got 2 different probes here. So every time I do tool height offsets, I have to go into the settings and change what the probe pin is being used for, which is a little frustrating. Mach 4 would let you have, I think, up to 4 probes at a time. So if anybody's still doing development on Mach 3, maybe add that. That would be cool. So the process I go through to set the tool height offset is I put my tool height offset probe on the workbench. I take all the tools out of the spindle and I probe this as 0. So this probe is actually telling the machine that this is going to be Z0. And I do that with the regular probe Z macro. And then I lift the machine up, put whatever tool I want in there, tell Mach 4 what tool I just put in, and probe it using the set tool height offset button. And that'll come down and probe it same way it probes Z, except instead of telling the machine it's at 0 on the Z axis, it figures out the difference between that Z0 and what it just measured and spits that out as the tool height. And will automatically populate your tool table with whatever tool you have selected and that tool height. So it's pretty automatic. I can run through 24 tools in 5 or 10 minutes. Pretty handy. Other than that stupid thing where I've got to change the pin number on the probe. Okay, that was probably the most talking I've ever done in a video. I hope you enjoyed it. I hope it didn't bore you to death. Normally I'm a pretty positive person, but I think Mach 4 was just starting to drive me a little loony, so had to get a few things off my chest. But I'm in a much better place now. The Mach 3 screen set I made has been really good for me so far. Hopefully there's a few of you that will find it useful as well. Who knows, maybe it'll even inspire a few people to make their own now that they know how good Mach 3 can look. Like I said, I'll make all this available, so check out the links in the description. But that'll do it for now. To make up for all of that talking, I think we're gonna skip the comment section this week and save them up for next week, but instead just show you this thing actually making some parts. All right, see you guys.